Welcome back to the course C# Advanced Language Features. I'm Philip Ekberg, and now it's time to introduce records. The record type introduces a compact way of creating a reference type with a whole lot of useful functionality out of the box. You can use a record where you'd normally use a class. Creating a record requires much less code than creating the equivalent class. Let's take a look at how a record is created. It all starts with the record keyword. This keyword represents a record class. You could also specify a record struct. This determines if it's a reference type or a value type. The record keyword alone is the same as writing record class. Just like a class, you can give this type a name. Next is where we introduce a completely new concept that makes this very different from creating a class. The record is most often created with something known as a primary constructor. This uses a positional syntax to define the properties of this type. Each of the properties defined in this primary constructor will be a property on the type, as well as a required parameter on the constructor. You complete the record definition by ending with a semicolon. You can add properties, fields, methods, and everything that you'd normally use in a normal class by introducing a body, but let's explore that later. For now, the record is completed. What we've just introduced is known as a positional record. This simple and concise syntax generates a class behind the scenes, with a constructor and the properties that we defined. This is a reference type, and we can construct an instance of this record just like you'd do with a normal class. The primary constructor means that you are required to pass these parameters when creating an instance of this record. How is this really different from introducing a new class? What code is generated behind the scenes, and why would this be a better alternative than using a normal class? To find out, we can look at the record and the decompiled code. You'll first notice that this is in fact a class. It implements IEquatable, which indicates that this class generates some code that handles comparing one instance to another. The record gives you value-based equality out of the box. This is really one of the benefits of using a record. Next, you'll see all the backing fields for the properties as defined in our primary constructor. These are all read-only. This makes the record immutable, as long as you don't introduce additional properties that aren't defined in the primary constructor. This means you can't change the values of these properties and their backing fields once you've instantiated an object. Knowing that an object is immutable is again really helpful in multi-threaded applications. You'll see the constructor and that it takes the values in the order defined by the primary constructor. Further down, we can see that the record overrides toString and has a method called printMembers. This means we can get a string representation of the record and its values. This could be very handy in logging. Then the record introduces the equality operators. This will use the equals method, defined in the interface IEquatable. If we look at that implementation, we can see that it compares the type through the equality contract, and then compares the backing fields from the two instances. Do you know what this means? This means we have value-based equality. When you compare two instances of the record, it will compare the reference But if they're not similar, it will also look at the values contained in both instances. The record also introduces a copy constructor. Finally, at the bottom of this generated class, we can see a familiar method, and here we have a deconstruct. This deconstructs the record with the same out parameters in the same order as defined by the primary constructor. This means that if we have an instance of this record, it can easily be used with pattern matching and the positional pattern. We could, of course, use the property pattern with the record, as each of the properties defined in the primary constructor are also accessible. Let's construct two instances with the same values and compare them. As long as the values are identical, the equality check will return true. What happens if we introduce inheritance? We can create a record that inherits from the previous record. This requires that you pass the parameters to the primary constructor defined by the record that you inherit from. You can use constant values, or you can add them to the inherited record and pass them along to the base record. These two records have the same properties and backing fields, and the properties live on the base record. What happens if we now compare an instance of the base record with the inherited record? This comparison will result in false. This is because the record uses an equality contract, which basically uses a reference to which type the record is. Since the types are not equal, it won't even go ahead and check the backing fields. This may come as a surprise, and therefore it's important to keep in mind. Because records are immutable, we cannot change the values of those properties defined by the primary constructor. If the primary constructor happens to use a reference type, there's no guarantee that this reference type is immutable. As an example, consider if the record has a property defined that accepts a list. There's nothing that prevents anyone from adding more elements to that list. The only thing that is immutable, in this case here, is the reference to that list on the record. You cannot dereference the property on the record to point to a new list. If you'd really like to change a property, how do you do that? We've seen immutable types previously in this course. So by now, you might have guessed that we can introduce the with expression. Just as with the anonymous type, you declare which instance you want to copy and which properties that you want to change. The result is a new instance. Records are a very welcome addition to C#. It makes it easy to remove the boilerplate code that we generally have to introduce ourselves. This compact syntax of defining a reference type is not only easy to read and understand, it is also very powerful. While records can be used in most scenarios where you'd use a class, some libraries may have restrictions and rely solely on reference equality. As an example of this, you cannot use records in Entity Framework to define your entities. What you can do is use records throughout the rest of the application to define, for example, domain models. Records should be used when you want to represent data, not for classes that handles business logic. Records come with great functionality out of the box. But what if you want to override the behavior of one of the methods? Or introduce completely new methods and non-immutable properties? You can definitely do that, and we'll explore this next.